9.3. Adding vectors at angles. We're going to start by looking at what happens when you add two vectors that are at angles together visually. Now, these two vectors I've drawn can't be added in a perpendicular method because they're not perpendicular to each other. So instead, we need to break them down into their components. We're going to use red for the x component and yellow for the y component and blue for the second vector's x component and green for its y component. Once you have broken down the two vectors into their components, you can find the total x by combining the two x components together. This is the red plus the blue. You can also find the total y by combining the two y vector components together. This is the yellow and the green. Now you have two vectors that are perpendicular to each other, built out of the components of the original vectors. We can add this total x and total y together to get the resultant. The total y, which is the green and the yellow, plus the total x, which is the red and the blue vector, combine to create two perpendicular vectors. The resultant is drawn from the tail of the first to the tip of the last. Now, to add vectors together when they're at angles, to do it mathematically takes a few more steps, but it's done exactly the same way. To add these vectors at angles, you must first break down each vector into its component x and y vectors. I'm going to show this whole method with an example, so that way you can see how it's done mathematically as we go through it. We're going to use the vectors 10 meters at 20 degrees north of west, plus 15 meters at 30 degrees east of north. The first step is to break them down to their component vectors. The of statement is always written in order sine of cos. North is the y vector, and west is the x vector. This means x component is 10 cos 20 to the west, and the y component is 10 sine 20 to the north. In the other vector, the sine of cos means that east uses sine, and it's the x component, and north uses cos, and it's the y component. So x is 15 sine 30 to the east, and y is 15 cos 30 to the north. Make sure you write in the directions because it's going to be very important to keep track of which direction each component gets so that you can add them correctly together later. The next step is to combine these components into a total x component. The x components are 10 cos 20 to the west and 15 sine 30 to the east. So the total x is 10 cos 20 to the east, to the west, plus 15 sine 30 to the east. Now we convert our directions into plus and minus signs. West is a negative direction, east is a positive direction. This means that the total x is negative 10 cos 20 plus 15 sine 20, 30. This equals 1.89692 meters, and since it's positive, we know it's east. Be really careful. Don't round this too early or you're going to embed rounding error into your calculations. Save the decimal places and round at the very end. We're going to do the same with the y components. Combine the y components to find a total y. Y total is 10 sine 20 to the north, plus 15 cos 30, also to the north. The signs for both of these components are positive because north is a positive direction. This gives us y total equal to plus 10 sine 20 plus 15 cos 30, which is 22.38731 to the north. Now you have two perpendicular vectors, x total and y total, created by combining the components of the original two vectors. To find the resultant of our vector addition, you add these two perpendicular vectors together. The magnitude comes from the Pythagorean theorem, which is c squared equals a squared plus b squared. So the magnitude is the square root of 1.89692 squared plus 22.38731 squared. Now we can round because this is a final answer. Sig digs tell us we need 2 sig digs, so it's 22 meters. The angle is tan negative 1. You can choose whichever one to go on the top and whichever one you want to go on the bottom. In this case, I'm using 22.38731 north divided by 1.89692 east, which is 85 degrees north of east. The of statement matches the top and bottom I chose. In the end, 10 meters at 20 degrees north of west plus 15 meters at 30 degrees east of north gives us 22 meters at 85 degrees north of east.